In this lesson, we are going to talk about the modal analysis. All structure behaves dynamically when subjected to load or displacement. If the load applied very slowly, the acceleration value will be small and can be neglected, and the static load analysis can be justified. The acceleration of earthquakes cannot be neglected, hence the additional inertial force cannot be neglected too. The conclusion is, I recommended you to make a dynamic analysis for all buildings, not only for the building which is mentioned in the codes, because it is very easy to make dynamic analysis as we will see in the next lessons. The first step in dynamic analysis is the modal analysis. The modal analysis is a powerful technique for understanding the structure behavior to validate simulation results. And modal analysis is the step 1 for response spectrum analysis and time history analysis. So here in our model, suppose that we have 2500 of joints. Let's assume that each point has 2 degrees of freedoms. So from this model, we can generate 5000 modal cases. So when the seismic acceleration is applied to each joint of the model with respect to single degree of freedom, different mode cases with unique model response are obtained, from mode 1 to n number of modes. So the response spectrum analysis will combine all these mode cases to obtain a single response for the structure. So we need to define the modal cases in Etabs. To do that, go to the Define menu, then click on Modal Cases. Here, as you can see, we have a previous modal case, so I am going to modify it by clicking Modify Case. Here we have 2 types. I recommended you to use rates. Here is the B delta, which we have defined before. Now, in the load applied for, as the earthquake doesn't cause a direct force on the building, it causes acceleration. So I am going to add 3 loads, and I will change their type to acceleration. Then choose UX, UY, UZ. For the target ratio, we need at least 90% of modal participating mass ratio. So change all of this value to 90%. Now, for maximum numbers of modes, I recommended you to take it 2 times of the number of the stories. However, I am going to take it 7 to show you the difference. Now, let's analyze the model. The analysis of the model is completed, and after the analysis, we need to check that whether the number of modes which we considered is sufficient or not. And according to the codes, the modal participating mass ratio should be at least 90% of the actual masses along both directions. In our case, we have considered 7 numbers of modes. So to find out whether it's sufficient or not, go to the result branch, then modal result, then click on modal participating mass ratio. As a result of that, a new table has opened up and showing the modal participating mass ratio. Now go to the last model to see if the sum reaches the 90%. So along the X and the Y direction, the sum of the 7 modes is 84%. So we have to increase the number of modes. So to do that, let's unlock the model. Now go to the Define menu, then select Modal Cases. Here click Modify. Under the maximum number of modes, take it to multiply by 19. Now let's analyze the model again. The analysis of the model is completed. So go to the modal participating mass ratio again. Now go to the last model. As you can see, the model mass sum has reached more than 90% along all directions, which means that the 48 numbers of modes is adequate for considering the dynamic analysis. Also, if you want to see the modal shapes, click F7 from your keywords. Now in this form, click on Mode option, then select the first mode, then click Upload. Now click on Start Animation Bot. As a result of that, you can see the first mode shape. By this way, if you want, you can see any mode you want by changing the mode number. Now it is the end of our lesson. In the next lesson, we are going to learn how to define the response spectrum.